Chapter 1. Notches. The oldest mathematical object in the world is a piece of a baboon's leg. It was found in a cave in the Lubombo Mountains, on the border between South Africa and Eswatini, and it is roughly 43,000 years old. It is a fibula, a slender lower leg bone, about the length of your hand, worn smooth, and cut across its length with 29 notches. The cuts are deliberate. They are evenly spaced. They were made one at a time, and then the bone breaks off. Whatever came after the 29th notch is gone, along with everything else we would like to know. 29 is a tempting number. The moon takes about 29.5 days to run through its phases, and it is easy to imagine someone watching that slow silver arithmetic in the sky and marking it down. It is also easy to imagine that the notches counted something else entirely. Days of a journey, a debt, kills, a game whose rules died with its players. Some have suggested the object was simply gripped better with grooves in it. The honest answer is that we have no idea. A bone cannot tell you what it meant. But here is what the bone does tell us, and it is enough to build a civilization on. 43,000 years ago, a human being took a thing that existed in the world and made a mark that stood for it. That is the whole trick. Everything in this book is downstream of it. The Lubombo bone is not alone. Notched objects turn up across the ancient world in a scatter that spans continents and tens of thousands of years, which tells us that whatever people were doing with them, they were doing it everywhere. In 1937, in what is now the Czech Republic, archaeologists digging at Dolní Věstonice pulled a wolf's forearm bone out of the ground. It is around 30,000 years old and carries 55 notches, and this one has structure. The marks are cut in groups of 5. After the 25th, there is a notch of a different size, longer than the rest, as though somebody had reached a landmark and wanted to say so. Groups of 5. A mark to say here is where I got to. Whoever made that bone was not just recording, they were organizing. They had noticed that a long row of identical marks is hard to read at a glance, and they had solved the problem in exactly the way you would solve it today, with a pen and a napkin, keeping score. The most famous of these objects came out of the ground in 1950, on the shore of Lake Edward in what is now the Democratic Republic of Congo. The Ishengo bone is another baboon fibula around 20,000 years old, and it still has a sharp shard of quartz wedged into one end. It was a tool meant for cutting or engraving, and someone covered its handle in tally marks. There are 3 columns of them. One column runs 11, 13, 17, 19. Which, a mathematician will notice immediately, is every prime number between 10 and 20. Another runs 11, 21, 19, 9, which is 10 plus 1, 20 plus 1, 20 minus 1, 10 minus 1. The third contains pairs that look like doubling: 3 and 6, 4 and 8, 10 and 5. 2 of the columns add up to 60. You can see why this bone has generated 80 years of argument. It has been read as a lunar calendar, an arithmetic table, a menstrual record, evidence of prime numbers 20,000 years before the Greeks, and a coincidence. The trouble is that a small collection of numbers will always contain patterns if you are hungry enough to find them. That is a fact about patterns, not about the past. Sober scholars mostly counsel patience. Something is going on in those columns. We do not know what. What we can say is more subtle and comes from a microscope. In the 1960s and 70s, an American researcher named Alexander Marshak examined marks like these under magnification and argued that within a single object, the notches had been cut by different tools, at different angles with different pressures. If he was right, and this too has been argued over, then these bones were not carved in one sitting as decoration. They were filled in over time. Somebody came back. Somebody added to the record days or weeks or months later, and expected it to still mean what it had meant before. That is a person keeping track. That is, in the most literal sense, someone doing their books. So what is a tally really? Picture the problem it solves. You have a flock of sheep. In the morning, they leave the pen and scatter across the hillside. In the evening, they come back. You need to know whether they all came back. And you do not know how to count. Not you are bad at counting. You have no number words. Nobody in your world has number words. The concept has not been invented yet. Here is what you can do anyway. As each sheep goes out in the morning, you drop a pebble into a pouch. 1 pebble, 1 sheep. You are not counting them, you are pairing them. In the evening, as each sheep comes back, you take 1 pebble out. If the pouch empties exactly as the last sheep walks in, everything is fine. If the pouch still has 3 pebbles in it when the flock is home and settled, you know with total certainty, without ever knowing a single number, that you are missing 3 sheep. You know it even if you have no idea what 3 means. Mathematicians call this one-to-one correspondence, and it is one of the deepest ideas in the subject. It says that you can compare 2 collections without measuring either of them, simply by matching them off, one against one, and seeing what is left over. Every child who divides candy by dealing it out around a circle is using it. Every notch on every bone is using it. Hold on to this idea. It will look humble for the next 19 chapters, and then, in the hands of a lonely and embattled German mathematician named Georg Cantor, it will be turned on infinity itself, with results that will look like madness and turn out to be true. Now, the part that is genuinely hard to believe. Counting is not natural. It is a technology, and it had to be invented, and the invention was difficult. We do come equipped with something. Show a person a scattering of dots for a fraction of a second and ask how many there were, and up to about 4, they will simply know. Not count, no, instantly, the way you know a color. Psychologists call this subitizing. Past 4, the ability falls off a cliff, and you find yourself doing something entirely different. Counting or guessing. That guessing is also built in. Humans have a rough, foggy sense of quantity that works at any size, but gets blurrier as the numbers grow. You can tell 20 berries from 40 at a glance. You cannot tell 39 from 40 at any glance at all. And we are not special in this. Crows can keep track of small numbers of people entering and leaving a hide. Chimpanzees trained on symbols will order them by quantity. Fish prefer to join the larger shoal. Honeybees, in a result that ought to be more famous than it is, can be trained to recognize none as a quantity smaller than 1, which is more than most human civilizations managed for the first several thousand years of writing. But none of that is counting. An animal with number sense knows more and fewer. Counting is a stranger and stricter thing. A fixed sequence of words in a fixed order, 1 word per object, no skipping, no repeats, with the last word you say standing for the whole collection. That final move is the sly one. When a child counts 7 marbles and says 7, they have just used a word that named the 7th marble to name the entire group instead. It takes children a long time to get this, and they get it suddenly, and until they do, they will happily count to 7, and then, when asked how many there are, count again from the start. Some human languages never took this route at all. The Piraha in the Brazilian Amazon have been described as having no exact number words, only terms along the lines of a small amount, a larger amount, and many. Asked to lay out a row of batteries to match a row placed in front of them, Piraha adults do well with small quantities, and drift into approximation as the rows grow, matching what looks right rather than what is exactly right. Their neighbors, the Munduruku, have words up to about 5, and use even those loosely, the way we use a handful. This is not a deficit of intelligence, and it is important not to hear it that way. It is a deficit of tools in a life that does not require them. Exact counting matters enormously if you own things, store things, trade things, tax things, and owe things. It matters much less if you do not. Number, as one anthropologist put it, is not a discovery about the world. It is an invention for dealing with a certain kind of world. We built that kind of world. And so we built number. The first calculator was the hand. The evidence is embedded in the words we still use. A digit is a numeral and also a finger, from the Latin digitus, and no one bothered to distinguish them because there was no reason to. 10 and 20 are the sizes of a person, fingers, then fingers and toes. French still counts 80 as Katervinks, 420s. Lincoln opened the Gettysburg Address with 47 years ago, meaning 87, and the word score comes from an Old Norse word for a notch, a mark cut into a stick. It came to mean 20 because when you counted livestock, you cut a notch for every 20 animals that passed. There is a scratch on a bone, fossilized inside one of the most famous speeches in the English language. Other cultures mapped number onto the body far more elaborately. Among the Oxapmin of Papua New Guinea, Counting runs along a route of 27 body parts. Up one arm from the thumb, across the shoulder and neck, over the nose and eyes and ears, and back down the other side. To say a number is to name a place on yourself. There is no separate word for the quantity, the elbow simply is that many. And if you are wondering why our clocks have 12 hours and our years 12 months when we have 10 fingers, try counting the small bones of your fingers with your thumb. 3 segments on each of 4 fingers. 12 on one hand. Now hold up a finger on the other hand for each full 12 you complete, and you can reach 60 before running out of body. Remember that number? It is where we are going next. Meanwhile, the tally stick refused to die. For roughly 700 years, the Treasury of England kept its accounts on notched sticks of hazelwood. A debt was recorded by cutting notches of standardized widths across a stick. A hand's breadth for £1,000, a thumb's breadth for 100, on down to a bare scratch for a penny. Then the stick was split lengthwise through the notches, so that both halves carried the identical record. The creditor took one half, the Treasury kept the other, and neither could be altered without the fraud becoming obvious the moment the two were laid side by side. The notches matched, or they did not. This was not a folk custom. This was the official accounting system of a European state, running well into the 19th century because it worked. When Parliament finally abolished the practice, it was left with 2 enormous cartloads of obsolete tally sticks, and, in 1834, decided to burn them in the furnaces beneath the House of Lords. The furnaces overheated. The paneling caught. By morning, the medieval Palace of Westminster had burned to the ground, an event so spectacular that Turner painted it twice. Charles Dickens, recounting the affair with obvious delight, noted that the country had clung to its sticks, long past the invention of pens and paper, and had been repaid for its stubbornness by losing both houses of Parliament. The oldest mathematical technology in the world went out in flames, taking a legislature with it. But the deeper story of the notch does not run through England. It runs through the Fertile Crescent, and it ends with something nobody expected. Beginning around 10,000 years ago, as people across the Near East settled into farming, they began making small clay tokens, thousands upon thousands of them in dozens of shapes. Cones, spheres, discs, cylinders, tetrahedrons, some plain, some scratched with lines. Archaeologists dug them up for a century and mostly ignored them, filing them as gaming pieces or amulets or the ancient equivalent of junk from a drawer. In the 1970s, an archaeologist named Denise Schmandt-Besseret looked at collections of these tokens from across the region and noticed they were the same. Not similar, the same shapes, appearing in the same combinations over thousands of miles and thousands of years. They were not toys. They were a vocabulary. A cone might mean a small measure of grain, a sphere a larger one, a cylinder an animal. Each token stood for a thing, and one token meant one of that thing, which is a tally, made portable. Instead of pebbles for sheep, you have sheep tokens for sheep, and now the marker carries not just how many but of what. Then, around 3,500 BCE, someone hit a problem. If you send a shepherd across the countryside with a herd and a pouch of tokens, what stops him from removing a few? So the tokens were sealed inside hollow balls of clay, closed up and stamped shut with the owner's seal. Tamper with the ball and everyone can see, but now nobody can read the account without destroying it. The solution was so obvious that it is easy to miss how enormous it was. Before sealing the tokens inside, the accountants pressed them into the soft outer surface of the ball, leaving impressions. 3 cone-shaped dents on the outside, 3 cone tokens within. Now you could read the record without breaking it. And then, sometime after that, somebody noticed the thing that changed the world. If the marks on the outside tell you everything, you do not need the tokens on the inside. The clay ball collapses into a flat tablet. The impressions become signs. Within a few centuries, the signs are being drawn with a cut reed instead of pressed with a token, and picking up other jobs along the way, names, titles, verbs, whole sentences. And what began as a way to stop a shepherd stealing sheep has become cuneiform, the first writing in human history. We did not invent writing to make poetry or scripture or law. We invented it to keep the books. The overwhelming majority of the earliest tablets from Mesopotamia are receipts. So much barley, so many sheep, so many jars of beer, so many days of labor owed. Literature arrives more than half a millennium later, writing a technology built by accountants. One last thing had to happen, and it is the one that makes this a chapter in the history of mathematics, rather than the history of paperwork. In those earliest tablets, the numbers were not free. Mesopotamian scribes used several different systems of numerical signs, and which one they used depended on what they were counting. Discrete objects, sheep, people, jars, took one system. Grain measured by capacity took another. Land area took a third. The same mark could mean different amounts in different contexts, and a scribe simply knew, the way a cook knows that a cup of flour and a cup of coffee are different sorts of promise. Think about what that means. In the beginning, there was no such thing as 3. There was 3 sheep and 3 days and 3 baskets of barley, and these were separate ideas that lived in separate compartments. The number was welded to the thing, and then, slowly, over centuries, the weld broke. The scribes began writing the quantity with one sign and the commodity with another, pulling the number out of the object and setting it down on its own. It is hard to overstate how strange this was, because it is impossible for us to see it as strange. You have known since you were 4 years old that 3 sheep, 3 days, 3 sorrows, and 3 stars all have something in common, and that the something has a name. And that you can do things to it whether or not any sheep are present. That thought is not obvious. It is an artifact. It was manufactured in clay by people whose actual job was inventory. Once a number can leave the things it counts, it can be asked questions. You can ask what happens when you add it to another number, and the answer will hold for sheep and days and stars alike, forever, without your ever having to check. Number becomes a place you can go and look around in. That is the beginning of mathematics. Not the notch itself, but the moment the notch stopped being about sheep. None of the people in this chapter knew they were doing any of this. The person with the baboon bone was solving that evening's problem. The scribe pressing cones into wet clay was trying not to get cheated. Nobody set out to build a subject. What they were doing, all of them, was noticing, and then refusing to let the noticing evaporate. A thought held in the head is a fragile thing. It fades, it drifts, it argues with the thought that someone else is holding. A thought cut into bone is outside. It can be set down and picked up tomorrow. It can be handed to a stranger. It can be checked. Every proof in this book, every equation, every argument that has ever settled a question permanently is a descendant of that move. Taking something out of a mind and putting it where 2 people can look at it together and agree. For thousands of years, that was enough. The marks accumulated, the systems grew, the accounts balanced. And then, in a hot river valley between the Tigris and the Euphrates, people began doing something with those marks that no one had done before. They started to calculate, not just to record what had happened, but to work out what must be true. They did it in base 60. And they did it, as we will see, astonishingly well.